One very common type of exponential function that comes up in the real world a lot is when we're dealing with compound interest. So, if interest is earned in an account um, on uh, on the principal amount and then on the principal on the interest that was earned previously, this is what we call compound interest. So, for example, if I put $100 into an account and it earns $5 in interest, during, I don't know, maybe the first year, then I have $105 in there. And so for the next year, I'm going to earn interest on the total $105. Okay, that is what compound interest is. And we have this formula that tells us what it is. And what we're doing here is we've got this P, this is the principal, and this is the initial amount, okay, the initial amount in the account. And we're multiplying that by this, this multiplication factor that tells us how it grows. So we've got 1, which just represents that we're going to keep that principal. And then plus, we have this R over N. R is the annual interest rate. Annual interest rate. And we're going to write that always in decimal form. In decimal form. So, for example, 5% would be 0.05. And so we're saying, well, we have that extra percentage. However, we're dividing by n. N is the number of times that we're compounding interest per year. Okay, number of times compounded per year. Okay, and so what we're doing is we're taking that interest rate and we're splitting it up over the year. So if I'm compounding, each month, so 12 times per year, then I get a 12th of that percentage increase each month. Okay. Then we raise it to the n times t. T, of course, is time. Okay. And so what we're saying, and this is years, almost always. Okay. Especially if we're talking about the annual interest rate. Okay. And this nt just says, well, if I have t years, then n times t is the total number of times that I'm compounding. So I've got this multiplication factor, which adds the interest to it, and I do it this many times, n times t over t years. So there's our formula for compound interest.